Hello and welcome to the video on parallel lines and transversals. By the end of this video, you should be able to differentiate between different types of lines that do not intersect, as well as be able to classify the different types of angles created by a transversal. Let's start with a few definitions. Our first definition is what parallel lines are. Parallel lines are coplanar lines that do not intersect. By coplanar, remember that means they are on the same plane. So if I draw two lines on the same plane that never intersect each other, those two lines would never get closer together, they'd never get farther apart. Common example of this, people talk about railroad tracks all the time. They have the same slope, they're never going to get closer together. Some notation they use for parallel lines, if you ever had two lines that were parallel to each other, you could show that they're parallel by putting the same number of arrows on them. So if line L and line M were parallel to each other, I could put the same number of arrows on those. Those arrows there, that means that they are parallel. If I had more than one set of parallel lines, and I wanted to mark that these were parallel to each other as well, I could say that lines A and B are parallel to each other, and I'd use a different number of arrows. Since I used two arrows on my first lines, L and M, I could use one or three, for example. But showing a different number of arrows there is saying that these lines are parallel to each other. I know that lines M and L would be parallel to each other, and lines A and B would be parallel to each other. The symbol for parallel is two vertical parallel lines. This is read as M is parallel to L, and A is parallel to B. Skew lines have a very similar definition to parallel lines with one difference. Skew lines are not on the same plane. So if I start by drawing two different planes that intersect each other, if you can visualize that as two pieces of paper running into each other, for example, skew lines would be lines that do not intersect, but they don't intersect because they're not even on the same plane. An example of this would be line L and line M. Line L and line M do not intersect each other. Line M is above line L, and they are never going to cross. Another example of this, if you can visualize a shoebox, because they're not in the same plane, line AB, if I would extend that out, and line CG are not intersecting. These do not run into each other, and they're not parallel to each other either. I know it looks like they're going to cross right here, but you got to look at it three-dimensionally. Line CG is in front of line AB. It's closer to you in the picture. Parallel planes are two planes that do not intersect. If I go back to that same shoebox I had drawn before, my parallel planes would be the planes that don't run into each other. An example of this would be the top and the bottom. Those two planes are parallel to each other. They would never get closer together. They're never going to get farther apart. They're parallel. Another example would be the sides. Those two planes there would also be parallel to each other. Our next definition is a transversal. Transversal is a line that intersects two or more coplanar lines at different points. So in this particular case, line T here is my transversal. It intersects two other lines, lines Q and R, at two completely separate points. You could have a transversal that intersects more than two parallel lines. In this case, this line right here would be a transversal, transversal A. It crosses these other three lines at three separate distinct points. Now that we know what a transversal is, we can talk about different types of angles that are created by a transversal. The first two types are interior and exterior angles. The names interior and exterior angles give away exactly what they're going to do. If I have my transversal T that is intersecting two other lines, R and Q, I've created 8 different angles here. The two angles on the interior of my two lines being intersected by the transversal are the 4 angles on the inside. So right in here, I have angles 3, 4, 5, and 6. Well, if that's what it means to be on the interior, it should be no surprise that the exterior would be the 4 angles to the outside of those two lines. So that's angles 1, 2, 7, and 8. Now that we know what interior and exterior angles are, there are going to be 4 other names that we will very commonly hear. You need to be able to differentiate these 4 things. Corresponding angles. The way I like to think of corresponding angles is that there's 2 groupings of angles here. Where line T and line Q intersect, there's this first group of 4 angles, And where line T and line R intersect, there's the second group of angles. The corresponding angles are going to give you one angle from each one of those groups, and they'll be the ones in the same or corresponding locations. Angle 1 and angle 5 are both in the left-hand upper side of their groupings. Since they're in the same locations, they are corresponding angles. There are three other sets here. Angle 2 is a corresponding angle with angle 6, as are 3 and 7 and 4 and 8. Our next angle set, alternate interior angles, the name, like before, gives it away. Alternate interior angles. Well, first of all, these are amongst the interior angles, so I know I'm choosing from angles 3, 4, 5, and 6. Alternate interior angles are ones that are on the alternate side of the transversal and along different lines. So there's two sets here as well. Angles 4 and angle 5 are one set of alternate interior angles. Angles 3 and 6 would be the other set. Alternate exterior angles, using the same logic, are angles that are on the exterior of my two lines and on alternate sides of the transversal. So again, I have two sets here as well. Angle 2 and angle 7 would be one set of alternate exterior angles. Angle 1 and angle 8 would be the other. And our last type, consecutive interior angles. Consecutive interior angles are again from the interior angles. These, however, are on consecutive sides of the transversal. That means they're on the same side of the transversal. So I have angles 3 and 5 and angles 4 and 6. Now that we can differentiate between these four different types of angles, let's try a few examples. We have a figure shown. It has points A through H listed on it. We want to answer the questions. Name all planes that are parallel to AFE. First thing we should do is find plane AFE. We know we can name a plane by 3 points on that plane. So plane AFE is the left side over here. The one that would be parallel to that would be the one that never intersects it, so the one over here on the right. We have 4 choices for points on that plane. I can just choose 3 of them to name that plane. I'll call it plane DCG. Part B, name all segments that intersect DH. Again, let's find DH first. Well, there are a number of them here that intersect at D, and there are some others that intersect at point H. So line segments AD, DC, EH, and HG would all be segments that intersect at DH. Part C, name all the segments that are parallel to GH. GH is on this particular plane, DCG. On that plane, there is line segment DC, which is parallel to it. Line HG is also on plane EFG, so there is a line segment there that is also parallel to it. And now the plane's not drawn in, but there's really another plane here, plane ABG, the plane that goes diagonally through here. That plane also has a segment called AB, which is parallel to HG. And part D, name all the segments that are skew to AE. So if I find AE, I would want all the segments that are not going to intersect AE because they're not in the same plane. BC is not coplanar and would never intersect AE. It is behind it. So would FG. And lines DC and HG are also skew to line AE. They also are in a completely different plane, and they don't have the same slope. They would never be parallel to each other. Example number 2, we want to identify the pair of angles as alternate interior, alternate exterior, corresponding or consecutive interior angles. Part A, angles 4 and angle 5. So if I find angle 4 and angle 5, I see they're along lines H and J using transversal K. So I can ignore line G altogether. Looking at these, I know they're on the same side of the transversal, and they're both to the interior of these two lines. It'd be consecutive interior angles. Part B, angles 7 and 11. For this picture, if I ignore line H, I notice that these are on the same spots in their respective groupings. They're both in the lower left-hand side. That means they're corresponding angles. Part C, angles 4 and 7. 4 and 7 are on the outside of these two lines. They're on opposite sides of the transversal. That would make them alternate exterior. Part D, angles 2 and 11. They're on the inside of these two lines and on opposite sides of the transversal. That would make them alternate interior. And part E, angles 8 and 11. Angles 8 and 11 are on the inside of these two lines. They're both on the same side of the transversal. That would make them consecutive interior. Let's try the same thing with a little more complicated picture. We want to identify the transversal for each set of angles and then name what type of angle set it is. Part A, angles 4 and angle 5. Well, those two angles are both on line A. That makes it our transversal. And they're also on the interior of these two lines on opposite sides of the transversal. That makes them alternate interior angles. Part B, angles 7 and 14. Those two angles are both along transversal D. They're both on the outside of my two lines, B and A, and they're on opposite sides of the transversal. That makes them alternate exterior angle. Part C, angles 4 and angle 6 are both along transversal A, and since they're on the same side of the transversal and both on the interior of these two lines, that would make them consecutive interior angles. And last but certainly not least, part D, angles 2 and angles 10. These two angles are both along transversal C, and in their respective groupings, they're both in the upper right-hand side. That makes them corresponding angles. And we are done.